people. Today we're going to be diving into lesson 3.1 and we're really going to be investigating what human activities can impact the environment. So we've been learning about carbon dioxide and methane. We're going to learn about how human activity is causing an increase in both of those gases. So this lesson has 4 parts. One of the parts we get to skip. We're actually going to skip part 3. Now, before you just dive right in here, I do want to point out that you need to watch the other video. The instructions for that are in Google Classroom. So is the video. All right. So for our warm-up today, we're still talking about those 2 main gases, carbon dioxide and methane, and how they've been increasing in the Earth's atmosphere. This prompt is asking you, what ideas do you have about this and why it might be happening? What could be causing the Earth's atmosphere to change? And for right now, we're going to dive into the human activities, but try to focus your answer here on some human activities that you know are increasing carbon dioxide and methane. Go ahead and pause the video once you've got this complete, and then we'll go on to the next part. All right, my people, here we are. Human activities, that's just things people do that affect the Earth system, at least for what we're talking about in this unit of study. Now, for this, for part 2, this is a sim investigation. It is a bit of a long sim investigation, but if you just take it step by step, it shouldn't be an issue. Plus, I'm also going to walk you through it. So, first thing you're going to want to do is open up your sim here. And we need to make sure that we select human activities mode once we're there. And we also need to open the graph once we're in there. So let's just do that real quick. I'll show you how. We're going to go up here and we're going to click on this panel. We're going to change it from Earth system to human activities. And then here is our graph, right? And we can toggle all of these things on and off. So we've got our temperature, we can get surface size, energy absorbed, carbon dioxide count, and methane count. So the first test, we want to have no change in the population. So we're going to run the sim until it reaches 30 and record those results. So let's do that. So I'm just going to push play over here. And the time's going. I can actually speed up the time if I want to. Let's go to 4 times. And we're supposed to go to 30. Okay, here we are. So let's take it one by one. That'll make it easier to see. So we see an increase in temperature, a drastic decrease in surface size. We see upward trend in energy entering versus exiting. In other words, energy absorbed. We can see that up here. We've got 186 units of energy entering and 110 leaving. Carbon dioxide, it's shooting right up, and methane is slowly rising. We're at 200, it's already 50% more at 300 parts. So let's turn all these on. So we would say we see an increase in temperature, energy absorbed, carbon dioxide, and methane, and a decrease in surface size. So that's what we would record for our findings here. Now, it says decrease the population to the lowest setting. Now, friends, I do want to stop right here for all of my friends who are not in my classroom. We'll talk about this in class, but I have a problem with this, and a lot of other people do, when we start talking about population reduction and we start talking about limiting the number of children people can choose to have. While I think it's important to have these conversations, I also think it's important that we have freedom, and especially the freedom to live a prosperous life and have offspring, right? And there are certain advocates saying we need to have limits on children, we need to have population control. And to me, that's kind of a scary thing. So just wanted to share some of my thinking behind that with you. But let's continue on. Decrease population to the lowest setting. Run the sim until it reaches 60 and record those observations. So we're already at 30. So I'm going to take my population, and it's at 7 billion. We're going to bring it down to 1 billion. And again, this is why I have the problem. How do we go from 7 billion to 1 billion without a lot of people perishing, right? So to a lot of people, this is kind of a scary thing to start talking about. Oh, we just need to reduce the population. But anyway, we're going to do it because the sim's asking us to, and it is a good mental exercise, so let's go for it. We're going to run this sim until we get to 30. I'm sorry, 60. And here we are. So let's see what we have here. Well, from the 30, it kind of peaked after that, and then it started to trend down, so maybe the temperature started to go down just slightly. The other thing that happened was our surface ice that had been decreasing became steady. Another observation is that the energy entering and exiting, remember it was trending upward before, now it might actually be trending down just a touch, right? And then the energy entering and exiting kind of shows that too. There's only a net difference of 12 now, whereas before it was 76. So let's take a look at carbon dioxide. So carbon dioxide peaked right up here, and then when we wiped out a big portion of the population, it started going down. And then methane, again, we see a steady rate increase, and then it plateaus, and then it's a little bit less than it was. It's below that 300 mark now. So those are observations that we will record here. Then we'll go on to increasing the population. So go ahead and pause the video at any point. I'm going to keep rolling though. So now we have to go to 90, make our time go to 90 with the population turned up to 12 billion instead of when. And we have hit maximum carbon dioxide apparently. And let's see what that looks like. Oh my goodness, yeah, the sim won't even take it higher than that, even though there have been times in Earth past where it's been much higher. We're just limited with the sim. So let's take a look at these. What did we get? Temperature, we see that increase. Surface ice, we are down to 0 now. Ooh, not good for the polar bears. Our energy entering versus energy exiting is way back up there again. Our carbon dioxide, as we saw earlier, is way up there at 620 parts per million, and our methane, which started at 200 way back over here, has gone all the way up to 480. So let's go back and record those observations here. And now we're going to go on to the next part. So it looks like we do need to reset the sim now. And we're going to focus on combustion. So we're going to reset it. And we're going to do no change to combustion. We're going to turn on our graph. We're going to run it for 30. Speed things up a little bit. And pause. Okay, let's see. What are our observations? Decrease in surface ice, increase in temperature, increase in energy absorbed, increase in carbon dioxide, and an increase in methane. So this is showing the trend of where we are currently, at least according to the sim, where we're seeing an increase in these gases and temperature and a decrease in surface ice. So let's record those and we'll move on to the next one. Don't forget to pause if you need to. Now you're going to run the sim until it gets to 60. Oh, what are we doing? Decrease combustion to the lowest setting. Well, the lowest setting is none. So let's run it for another 30 count in our time and let's see what happens. What? Okay, so our temperature has actually started to level off. It was going up at a steady rate. let's look at our surface ice. So our surface ice is still it still went down. Our energy absorbed still went up a little bit, but you'll notice the difference here of 75 versus here of less than 20, only 17. So we can see that the trend is starting to come back the other way. And then carbon dioxide, we have decreased from where we were. We're down to less than 300 parts per million. And then methane, of course, combustion is the burning of fossil fuels. And methane is produced by mostly agricultural practices, so farming. And so we didn't impact that at all by changing our combustion. So let's record those observations there. And now we're going to do the super crank. Crank it all the way up. And we are going to push play. We're going to go to 90, and we're going to see what happens. This is interesting. I left the methane on, and it's still, I went too far. 99, close enough. The methane, you'll notice, is still increasing because, again, we haven't touched the livestock. That'll be the next part. So we got our temperature. We see that starting to go back up again. Our surface ice is down to 0. Our energy is what that's entering and being absorbed is super high. Carbon dioxide is maxed out again. So we can see what that result will have by increasing combustion. So let's write down our findings, and let's go to part 3 here. So for part 3, we are still in the sim, and we're basically doing what we just did again, except we are, did I reset it? Reset, yes, okay. Except we're going to be focusing on livestock primarily. So no change to population. Run the sim until it reaches at least that time. Now we've already done this, so you can literally just go back, copy and paste, because we've already gotten to that point before, right? Now we're going to decrease the population, so we still do need to run the sim, and we need with no change until we get to 30. There it is, 30, boom. And again, we don't need to record, or we can just copy and paste those observations because we didn't change anything. But now we are going to decrease the population to the lowest setting. Wait a minute. Increase the population. We already did this. Just copy and paste that stuff. So let's just skip to part 4. Sorry guys, not sure why Amplify's asking us to do the same stuff. So no change to livestock per person. Reset the sim, run until it reaches. Again, copy and paste from here because it will be the exact same. All right, now we're ready to test what we do when we increase livestock. So the first thing we're going to do is decrease the livestock to the lowest possible, and we're going to push play. We're going to go to 60. We're going to see what happens. And touchdown. So we still see a temperature increase pretty significantly, even with livestock per person being where it is, probably because we're still using combustion. But let's take a look. We've ran out of ice. Our energy is absorbed more. Carbon dioxide is still up really high. And our methane, though, has started to come down. Remember, though, it started at about 200 parts per million, and it's still over that just a little bit. So, interesting. So let's record those findings there. Now we are going to do that same thing, but we're going to crank the livestock all the way up. And we're going to push play till we get to 90 and see what happens. Maximum carbon dioxide has been reached. All right, so that's pretty good there. So again, carbon dioxide is through the roof, and notice the methane has started to go up. We still have no ice left, and we can see that we were trending down just a little bit, right about here. But then I think that methane helped us and our temperature started to increase. So let's record those findings here and let's move on. So for part 3, we are actually going to skip that. Hooray! And we're going to move on to part 4. This is a modeling tool. And what you're going to do, your goal is to show one cause of carbon dioxide or methane increasing in the atmosphere and how this leads to temperature. So we've been learning about how human activities such as livestock, combustion, and we're also starting to learn a little bit about forest cover, and the more trees we have, the more it helps take away from our carbon dioxide in the atmosphere. So here's what we're going to do, friends. You can either choose methane or you can choose carbon dioxide. So I'm just going to go with carbon dioxide. And what I want to model here is kind of like what our temperature would be like. So we've already done modeling activities that kind of got us here. But now what we're going to do is we are going to add in some human activities. In this case, I'm choosing combustion. And we could say maybe we're like this with our, it's going to let me do forest cover. Nope, it's not going to. It's not going to let me do that one. Oh, anything. Let's try again. Well, it's as good as it gets, friends. But something along these lines. We could also show the energy absorbed. You could turn that to medium, turn this to high. And maybe we'll do the ice as low here. We'll ice as medium here. And then to really top this off as an awesome model, maybe we could say that one's kind of equal, but this one, I'm sorry guys, I'm really trying to grab this. And the modeling tool appears to be fighting back right now. There it is. Just had to kind of force it. So I also want to show more energy entering than exiting. Now, friends, push that hand in button and it will automatically insert it here. And then the last part of today's lesson is you're going to read Global Warming, the History of a Hot Debate. And thanks for watching. Don't forget to like, share, comment, and subscribe.